Welcome to the next conversation where we unpack the newly launched global industry standard for tailings management. This is the first of a two-part video discussing Principle 7, which talks about the monitoring requirements on TSFs. The question is, are you using or maximizing the latest and most cost-effective technology for TSF monitoring? And we'd like to get your feedback in the comments below. I'll discuss the first two items today. Movement monitoring. This is known as reactive monitoring, and it may be too late when movements start to do anything about them, as was the case with the Residue failure, which was associated with static liquefaction, or otherwise known as brittle failure. This method may be effective though for TSFs with embankments of clayey materials that exhibit a more ductile behavior and can be an early warning. There are a number of land and satellite-based surveying methods that can be used. Land-based methods typically set up an automated theodolite that continuously scans a TSF embankment and generates by exception reporting of unacceptable movements. Satellite methods can only provide information every orbit, and the accuracy depends on the resolution used. It typically reports on deformations or any differences from one orbit to the next. Inclinometer technology has also advanced over the last number of years, but needs to be applied correctly to be useful. Phreatic level or pore pressure monitoring. This is a proactive method of monitoring and provides water levels or pore water pressures within the slopes that are compared to critical levels associated with a minimum factor of safety. This data can be transmitted to a central database as often as deemed necessary and set up to a dashboard that triggers notifications when a change in compliance status is recorded. Standpipe and vibrating wire piezometers are the most common instruments used. Standpipe piezometers typically need to be manually read, are slow to react, and the frequency is often only once per month unless more frequent measurements are deemed necessary. It is possible to retrofit automated devices into standpipe piezometers to measure water level more frequently. Vibrating wire piezometers are becoming the standard as they can be linked to data loggers and gateways to transmit data to a central database. They are more expensive but provide more reliable data. Cost-effective technology exists that can be installed or used on all TSFs to manage safety and risk. Theft and vandalism on some TSFs is a significant obstacle to some of these measures. Knight Piersold is able to advise on practical and cost-effective monitoring systems that provide real-time data and dashboards, often in collaboration with the likes of Inmarsat and Sensemetrics. Please join me again for part 2 of this conversation.